In Australia, we probably all heard of the Great Barrier Reef. These corals are very rigid and can easily cut your skin. But do you know what their hard skeletons are made of? They're actually made of calcium carbonate. But have you ever thought about that one day the coral reef could be dissolved away and disappear because they cannot produce calcium carbonate anymore? Unfortunately, this could happen. This is because climate change will influence the dissolution and precipitation of calcium carbonate, and vice versa. So with more CO2 being emitted to the atmosphere and then absorbed by the ocean becomes more and more acidic. So that is what we call ocean acidification. So ocean acidification and calcium carbonate, they interact with each other. So on the one hand, ocean acidification will make the carbonate forming organisms such as corals hard to survive because they just cannot produce or maintain their calcium carbonate skeletons or shells. But on the other hand, ocean acidification may also bring us some benefits. Although it speeds up the dissolution of calcium carbonate and makes the carbonate forming organisms a bit hard to live, it also increases the ability for the ocean to take up more CO2 from the atmosphere. And it is predicted that this is one of the major ways to reduce anthropogenic CO2 over the course of next few millennia. Therefore, to predict how well the ocean will take up CO2 from the atmosphere, we first have to understand what governs the dissolution of calcium carbonate. Recent studies found that there's calcium carbonate dissolves in the upper ocean where it is not supposed to be dissolved. This evidence comes from the measurements of seawater total alkalinity, which is the budget of all weak acid and bases in a water solution. However, the total alkalinity can also be affected by processes other than calcium carbonate dissolution and precipitation. So this may give us inaccurate results. So in comparison, measuring calcium ion concentration in the seawater would be the most direct way to quantify the extent of calcium carbonate dissolution. And this is what I'm also working on. So if we can get this going, and we probably get more accurate data on calcium carbonate dissolution by using calcium. And from there, we probably can predict how the ocean and its ability to take up anthropogenic CO2, and probably as well as the survival of the carbonate forming organisms in the ocean, such as the Great Barrier Reef.